Countdown.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi, good evening to all teachers, parents, and students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with e-didik Malaysia and Kelab Guru Malaysia. Bermula percuma, selamanya percuma. So before we proceed, let's begin our session with the recitation of your prayers according to your religion. Okay, how is everyone doing today? I hope that everyone is okay and ready to proceed with today's class. Now, let me introduce myself. I am Teacher Eileen as your moderator for today. And together with me is our presenter, Cikgu Zainariah binti Abdullah from SMK Tunku Ampuan Durah Negeri Sembilan. And also our host controller, Teacher Im from College Tingkatan 6 Tapah Perak. Okay, for record, we are now live on Cikgu Zana's channel. So as a sign of support to Teacher Zana for the hard work in preparing today's lesson, please subscribe her channel. Not forgetting to Teacher Im and myself, Teacher Aileen too. So as usual, the lesson will last approximately for 1 hour, and the certificate link will be given at the end of this session. So be sure to follow the class up until the end and give your full cooperation in making this session a lively one. I would also like to remind students to use appropriate language and also use appropriate profile picture if you wish to post comments in the chat box. I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment.
Yes.
So stay focused, and if you have any questions, please write on the chat box and Cikgu Zana will try to provide you with the answers. So without further ado, please welcome Cikgu Zana.
Okay. All right. Okay. Good afternoon, students. Assalamualaikum and salam sejahtera. As usual, my full name is Teacher Zainariah. Okay. You can call me Cikgu Zana for short. Okay. So I'm a Form 6 Maths teacher from SMK Tunku Ampuan Durah. So can we share the slide now? Okay. Right. So this is my YouTube channel. So do not hesitate. Please subscribe my YouTube channel. Okay. Right. Next. Okay. This is the playlist for all the maths video lessons. So you can please feel free to browse through all the video lessons in the playlist. Okay. Do not hesitate to look up any video lesson that you wish. And we also have the video lesson on chemistry, the playlist, okay, and also the playlist for biology video lesson. And also not forgetting the playlist for account and economy for Form 6 and also matriculation matriculation. So for today's lesson, we're going to do a revision on random variables. That is, we're going to look at discrete random variables and continuous random variables. Okay, now. So what is a random variable? A random variable is just a set of possible values from a random experiment. In other words, random variable usually written as the big capital letter X, okay, is a variable whose possible values are the numerical outcomes of the experiment. Okay, the experiment is a random phenomenon. For example, here, if we were to toss a coin 3 times, okay, there is the experiment, toss a coin 3 times, and we let X be the number of heads. So our X is a random variable whose possible values are 0 heads, we might get 0 heads, or only 1 head, or 2 heads, or all 3 are heads. And we can write using the mathematical sentence as X equal 0, 1, 2, or 3. Okay, so this is example of a random variable. Okay, now, random variable consists of 2 types. The first one is a discrete random variables, okay? So what is a discrete random variable? A discrete random variable is one which may take on a countable number of distinct values, such as 0, 1, 2, 3, 4, and so forth. And in other words, discrete random variables are usually counts. They are countable. We can count them. For example, like counting the number of children in a family, counting the attendance on a Friday night cinema, counting the number of patients a doctor sees in one day, counting the number of defective light bulbs in a box of 10, and counting the number of heads flipped in 3 trials. Okay, all these are discrete random variable. Okay, next. The second type is the continuous random variable. Okay, so continuous random variable, it takes an infinite number of possible values, meaning that the values lies in an interval. And continuous random variables are obtained using measurements. We measure them. For example, we measure the height. It could be the height of students. We can measure the weight of students, or the weight of people, or the weight of workers. And we can measure the amount of sugar in an orange, or we can measure the time required to run a mile. Okay, see the difference between discrete and continuous random variable. Okay, so from the random variable arises 2 types of probability distribution. We have the probability distribution of a discrete random variable. Okay, here on the left-hand side of the diagram, we have the probability distribution of a discrete random variable. Okay, it is just a table. Sometimes it can be displayed in a table or a graph. Here I'm showing you a graph that specifies all the possible outcomes of a random variable along with their respective probabilities. Okay, X are the random variables. The height of the bars represent their respective probabilities. So this is the graph of a discrete random variable. Whereas the probability distribution of a continuous random variable is defined by its probability density function, which can be shown by a curve. Okay, it's shown by a curve. So that's the difference between discrete and continuous random variable. Okay, we can see the comparison of these two variables. Okay, let's summarize. For discrete, it's countable. Okay, and it has discrete points. On the graph just now, it has discrete points. And the probability distribution function is denoted as Px. And the condition to show that it is a discrete probability distribution, it must satisfy all the probabilities are non-negative and that the sum of the probabilities must be 1. Okay, so this is the condition to show that it is a discrete probability distribution function. For continuous, okay, on the right side here, it is uncountable and the values lies in the continuous interval and the probability density function is denoted as f of x and the condition for it to be a continuous probability distribution is, again, the probability density function must be non-negative, but this time the total area under the curve must be 1. Remember just now our definition for continuous random variable, it is shown by a curve. Okay, so this is the condition to show that 1, discrete probability distribution, and the condition for continuous probability distribution. Okay, so what must student know? Okay, this is a revision. Okay, I'm summing up to see the difference between discrete random variables and continuous random variables. So for the probability distribution, for discrete, the symbol is Px. It's just finding the probability of the outcome. But for continuous random variable, the probability lies in an interval. So to find the probability, you must integrate the probability density function within the interval. So the interval represents the limits. So for this topic, especially for continuous random variable, please ensure that your skill in integrating and differentiating is good because you need them both to find the probability density function. Okay, and then you are required also to find the cumulative distribution function. The word cumulative means we accumulate the probabilities. Okay, we accumulate the values of the probabilities. So the symbol is big F of x that represent cumulative distribution function. So for discrete random variable, we just add up all the probabilities. So if we have big F of x, it represents the sum of the probabilities that is less than equal the small x. Okay, the small x represent the variable. But for continuous random variable, okay, to find the cumulative distribution function, you have to integrate all the function from the interval, from all the intervals less than equal x. Okay, from negative infinity to x. Okay, and then you must know how to find the expected value, or sometimes they say mean of x. So for discrete random variable, the expected value is the sum of the product of the variable with its probability, and the symbol sometimes used is mu. Whereas for the continuous random variable, it's the integral of the product of the function the function f of x with its variable x. Again, the symbol is mu. Okay, and then also students must also know how to find the variance of x. It's just the sum of the product of x squared with its probability minus the mean squared. Okay, or we can use the expected value ex squared minus the mean squared. And for continuous random variable, okay, the variance of x is the integral of x squared multiplied by the function f of x from negative infinity to infinity minus the mean squared. Or we can use the expected value ex squared minus the mean squared. And for continuous random variable, you can get the probability density function by differentiating the cumulative distribution function. In fact, for discrete random variable, you can also get the probability distribution function by subtracting from one cumulative to another cumulative. Okay, later on we will be doing this in one of the examples. I don't know why my cursor is not shown on the slide. Probably because I'm
Cikgu Sana, we can see your cursor.
Okay, right. Thank you. Okay, next. Okay, now sometimes we need to find the probability given a cumulative distribution function. So here the first one is the definition of a cumulative distribution function. So to get the probability of x which is less than equal a, we just find f of a. But to find the probability of x between a and b, we use f of b minus f of a. And to find the probability of x greater than a, we use 1 minus bx less than equal a, which is actually f of a. Okay, so we can find the probability whether it is distribution function or density function. We use the formula. We use these formulas. Okay. Okay, now from the discrete probability distribution, we can arises special probability distribution. For discrete, we have a special probability distribution known as the binomial distribution. Okay, here x is binomially distributed with parameters n represent number of trials, p represent the probability of success. So this is the formula of getting the probability. And notice that r, okay, from 0 to n is the number of trials. To find the mean of the binomial distribution is just n multiplied by p, and the variance is npq. And the second special distribution is the Poisson distribution, okay, with parameter just lambda. Lambda is the mean and variance of the distribution. And to get the probability, we use the formula e to the power of negative lambda multiplied by lambda to the power of r over r factorial. Okay, but sad to say for this session, I'm not going to show any examples on this special probability distribution, but you can look at our video lessons on this special probability distribution. Whereas for continuous probability distribution, we have only one special probability distribution, which is the normal distribution with parameters mean mu and variance. This is a normal distribution, hence to get the standard normal distribution, you have to use the z-score. Okay, you have to standardize it using the z-score formula. X minus the mean mu divided by the standard deviation. And take note, a binomial distribution where n is very large. This is just a guideline. But then here the condition np greater equal 5 and nq greater equal 5 is already a good indicator that the binomial distribution can be approximated to a normal distribution. Okay, here we write as x normally distributed with mean mu as n times p and variance npq. Okay, there's a two school of thoughts. One school of thought says that you have to add the correction factor, the continuity correction factor, because it's from discrete to a continuous probability distribution. Some books says it can be ignored. So I do not know about Maths T scheme, but for Maths M, both are accepted. But normally I will teach my students to add the continuity correction factor. So please look up at your reference book or your textbook how to add the continuity correction factor. Okay. But for this,
for Math 3, we need to do correction.
Okay, right. So, okay, Teacher Eileen say for Maths T, you must add the continuity correction factor. But I always teach my student, you have to add, because from discrete to continuous, you have to add the continuity correction factor. Although sometimes the examiner says sometimes is diterima is accepted. For me, I would teach them the proper way. Okay, so please add the continuity correction factor. That's the proper way. Okay, now loss of mathematical expectation. I'm just sharing with you because one of the question later on, you have to understand how the loss are being used. Okay, it's just simple. The expected value of a constant is the constant itself. Okay, the expected value is just the expected value. And the expected value of x plus a is the expected of x plus a. It's just like distributive law, e to the power of x. Sorry, e like a function, e of x. E of a is a. And then we can take out the constant. So we have a ex. And if we have ex plus y, it's ex plus ay. And if we have ax plus by, you can, like distributive law, aex plus bay. Okay, this laws later on will be helpful when they ask to prove, okay, when to ask to prove a formula in the discrete probability distribution and also continuous probability distribution. Okay, here we have the loss of variance. Okay, I don't have to explain, just that for variance, if you have a variance, a constant ax, you have to square the constant a squared variance x. But variance of a constant is always 0. Okay, you can look at your reference book why it is 0. Okay, I'm just showing to you the loss of mathematical expectation and variance in order to help you to solve certain problems. Okay. Okay, now I'm giving you time to read and understand the question. Okay, this is already what I call it, revision. We start off with an easy question. So I'm starting off with a discrete random variable x. Okay, that has the probability distribution. Okay, as I mentioned earlier, it can be in a table form. So here the probability distribution is in a table form. When x is negative 60, the probability is p. When x is 20, the probability is 0.1. When x is 24, the probability is q. When x is 60, the probability is 0.25. Okay, now it is given that the probability of x less than equal 20 is 0.25. Okay, so determine, when the word here determine means you have to show working the values of p and q. So think of the concept that you're going to apply to find the values of p and q. Next, you need to find the expected value of x and the expected values in the bracket x minus ex, the whole thing squared. Okay, look at the marks. Here 2 marks, meaning that it's quite simple. Here 5 marks, meaning that you need to show the quite a few steps to get the answer. Okay, have you all got the okay? Can you try and do? I'll give you about 2 or 3 minutes. 3 minutes will do.
Yeah, students, you can try.
Yeah, this is an easy topic. The clue is that the probability of x less than equal 20 is 0.25 and that this is a discrete random variable x. So what is the property of a discrete random variable x? That's the clue. Okay, let's...
So if you have got the answer, please write it out in the chat box.
P is simple, or you just apply the clue that's given. The clue is that the probability of x less than equal 20 is 0.25. So what do we mean that the probability of x is less than 20? This is discrete, yeah? So it has a distinct point. So what does this mean? Px less than equal 20. So looking at the distribution table, we only have x equal negative 60, which is less than 20, and there's equal sign, so 20 is included. Okay. Oh yeah, there's one answer. P is 0.25, Q is 0.4. Okay, let me see. Okay, understand the meaning of Px less than equal 20. So we have to refer to the distribution table. Px less than 20, we have Px equal negative 60 and Px equal 20. Always refer to your distribution table. Okay, we have Px equal negative 60 because it's distinct points. Okay, distinct points. So the points are negative 60 and 20. So the probability of x equal negative 60 is P, and the probability of x equal 20 is 0.1. So P is just 0.15. Okay. Okay, good. Taulai. Every week, you without fail will be joining our tuition. Thank you. Thank you. Okay, now to find Q. So what is the concept that we're going to find Q? Since this is a discrete probability distribution, the sum of the probabilities must be equal 1. Okay. So we just add up all the probabilities. P plus 0.10 plus Q plus 0.25, we equate to 1. Substitute P as 0.15. So our Q is 0.5. Okay, congrats. Congrats, yeah, to the students who got the right answer. I could see there's a few of them who managed to get the correct answer. So this is an easy one, but it's only 2 marks. Okay, it's only 2 marks. So 1 mark each to get P and to get Q. Okay. Oh, now to get the expected value of x, so we apply the formula. Oh, part B, sorry. Oh, saya tak cari tu. Tak apa. Some of you managed to get the expected value of x, which is 20. I feel, okay, I missed out that step. Okay,
It doesn't
some of you...
matter. Leong On Wong has already got the answer. His answer is 20.
Yeah, good. Because I'm more interested in this expansion. Okay, to find the value of E in brackets x multiplied by EX the whole thing squared. So we expand this x multiplied by e to the power of x. Okay, so we have x squared minus 2x multiplied by EX plus EX the whole thing squared. So applying the laws of mathematical expectation just now, so we have EX squared. So 2x becomes 2EX, but EEX is just EX. EEX squared, EEX whole thing squared is just EX the whole thing squared. Simplifying, 2EX times EX is 2EX squared. Okay, minus 2EX squared plus EX squared, we have this. Okay, somebody has managed to find the value of EX for me. The mean is 20. Okay, so notice that the one that we expand is actually the formula for variance of x, EX squared minus the mean squared. If some of you might aware from starting that this is the formula for variance of x. So find EX squared. Okay, it's the sum of x squared multiplied by its probability. So you have 1768. So the variance of x is actually 1768 minus the mean squared. The mean is 20, is 1368. Okay, so I was expecting that, okay, and good. Some of you have already found the mean, which is 20. To get the mean is simple. You just multiply negative 60 plus 0.5, sorry, negative 60 plus 0.15 plus 20 times 0.1 plus 24 times 0.5 plus 60 times 0.25. So the value is 20. Okay, good. Those who have managed to get it, well done. Okay, meaning that you are on the right track. You have done your revision.
So,
Okay, next.
Zana, do you want to take a break?
Okay, yes, why not? Okay.
Misi pencarian ikon e-didik junior kini bermula. Siapakah yang layak dinobatkan sebagai ikon e-didik junior bagi tahun ini? Jom sertai misi pencarian ini. Syarat-syarat penyertaan: anda mestilah menyertai Pusat Tuisyen PERCUMA AYU dan juga mestilah mendaftar untuk mendapatkan ID AYU masing-masing. Juga perlu menjawab soalan yang akan diberikan pada setiap minggu. Dan akhir sekali, perlu menjalani ujian akhir bagi penentuan ikon e-didik junior. Jadi, apa tunggu lagi? Adakah anda ikon yang kami cari? Adakah anda telah bersedia? Peluang di tangan anda. Untuk maklumat lanjut, layari www.academyyoutuber.com.
Yes,
Okay.
now we are back.
Okay, thank you, Teacher Eileen. Okay, now the next question, again, discrete random variable. Here we have a cumulative distribution function. Okay, we have a cumulative distribution function. Okay, so it's quite lengthy here. This is a maths question. So from the cumulative distribution function, find property of x greater than 3. Show that the expected value is 1.4 and find the property of, modulus x minus the expected value of x less than 1. Okay. Don't worry, I have the function here. Okay, sometimes the question likes to show this px less than equal x. It is actually the cumulative distribution of the function big F of x. So to get the property of x greater than 3, okay, we use 1 minus px less than equal 3. Or the one that I've shown earlier, the formula is 1 minus the cumulative function 3, f3. So how to look for f3? X equal 3 here. The value of f3 is 0.9. Okay, so we have 1 minus 0.9, which is 0.1. Okay, next. To find the expected value of x, what must you do? Because here we have a cumulative distribution function. If I were to show this in a table distribution, we have this. Okay. When x is 0, f of 0 is 0. Sorry. When f is 0, your f of 0 is 0.3. When f is 1, f of 1 is 0.6. When f is 2, 0.8. When f is 3, 0.9. When f4 is 1. So this is the cumulative distribution function in the table form. Okay, do you have any idea why I wrote this in the table form? Because from here, we can easily obtain the probability distribution function. Okay, I always tell my students, it's easier if you put it in a table form because we just minus the previous cumulative distribution function. For example, here, how do I get 0.1? It's 1 minus 0.9 is 0.1. How do I get 0.1 here is 0.9 minus 0.8. Okay, we work backwards. 0.8 minus 0.6, we have 0.2. 0.6 minus 0.3 is 0.3. 0.3 minus 0 is 0.3. Okay, you need to get the probability distribution in order to get the mean. Okay, the expected value of x. Using the table is easier. So using the formula, we just multiply. So with a table it's easy if we can do it mentally, okay, but Okay, you can just straight away multiply 0 plus 0.3, 0.4, 0.3 plus 0.4. Okay, which is 1.4. Therefore, since this is a proving question, we conclude our answer. Therefore, the expected value of x is 1.4. Okay, understand? Okay, this is simple. From the cumulative distribution function, we can get the probability distribution function. Okay, now, they like to ask this. Find the probability in modulus sign, yeah? X minus the expected value of x less than 1. Okay, one thing nice about question asked in Stpm, if you cannot show part B, okay, you can do part C because the expected value of x is already given 1.4. So opening up the modulus sign, okay, we have x minus 1.4 in between -1 and 1. Okay, this is less than 1. Kalau greater than 1 is different, yeah. Kalau greater than 1 is px minus 1.4 less than -1.4 or px minus 1.4 greater than 1. But since this is less than 1, when you open up the modulus, is x minus 1.4 between -1 and 1. Okay, simplifying, we have this. Using the cumulative distribution function, we have f. Okay, sorry. Px equal 1, sorry. Px equal 1, sorry, I'm so sorry. Confused and continuous. This is discrete. So x lies between 0.4 and 2.4. Remember, this is discrete. They are points. So the points between 0.4 and 2.4, okay, 0.4 is only 1. The points are 1 and 2. Okay, this is discrete. So discrete points. So px equal 1, px equal 2. So 0.3 plus 0.2, which is 0.5. Okay. So this is an example of a discrete random variable whereby involves cumulative distribution function. Okay. Last, I already prepared 3 on discrete, 3 on continuous. Okay, the first part, I think all of you can do this. Given the expected value of x is 1.2, find the values of a and b. But part B is the one that I'm more interested to know whether you can show whether x is not a binomial random variable. Remember, binomial random variable is a special probability, is a special discrete probability distribution. So what is the condition? What is the property of a discrete probability distribution? For the first one, I think all of you can get this. Okay. So notice that the questions are consistently find the values of the constant A and B using the concept, okay, of discrete probability distribution. Okay, I have the table here. So first, we are given that the expected value of x is 1.2. So using the formula, 0 times A is 0, okay, plus B, okay, you just multiply x with its probability. You have the first equation. Since there are 2 unknown, so you have to get 2 equations. So the second equation comes from using the property that the sum of the probabilities must be 1. Okay, so we add up all the probabilities and we have the second equation. So solving these 2 equations, okay, 2 minus 1. We have 1 over 3a equals 0.1. So a is 0.3. Okay, I'm doing this fast because this is simple and we already did this in the first question. So this one is the same process, same procedure. Okay, now try to do B. Show that x is not a binomial random variable. Show that X is not a binomial random variable. So how do you show that it's not? Okay, sorry, this is A, this is my B. B is 0.35. Okay, just substitute into 1 to get your B. Okay, now, how to show that X is not a binomial random variable? Can any of you give me any properties? What must we do to show that it's not a binomial random variable? Already guided here. If X is binomial, so X has the parameter. Okay, the number of trial is 3, N is 3, but not 4, is 3. Okay, the probability of success is P. Earlier, I showed you R can be 0, 1, 2, until N. N is the number of trials. So here N is 3. Now, so how to show that it's not a binomial distribution? You must know how to show, then only we can work. Okay, my clue is discrete. So for discrete, binomial, the word bi means is either probability of success P and probability of failure Q. So for discrete, the sum of the probabilities must be 1, right? So we have to show that the sum of the probabilities is 1. If it's not 1, then it's not a binomial random variable. So you must find the value of P and you must find the value of Q. So to find the value of P, we use the probability of X equals 0 is 0.3. Okay, substitute into the formula. Okay. We find Q first. Okay. In working, make sure you run off to at least 4 significant figure. Do not run off to 2, at least 4, okay, in working. Then to find the next probability of success P, we use Px equal 3, 0.5. Substitute into the formula because we want Q to the power of 0, which is 1. Just now I said P. This is to find Q first. We use Px equal 0. Then we find P, we use Px equal 3 equals 0.15. So 3C3 is 1. So we are left with P to the power of 3. Using the calculator, P is 0.5313. And you add up. Remember, for discrete random variable, the sum of the probabilities must be 1. But when you add up, notice that the sum of the variables is more than 1. So X is not a binomial random variable. Okay, so remember this condition. For any discrete random variable, the probability distribution function satisfies the condition that the probabilities are non-negative and that the sum of the probabilities must be 1. Okay, so this is a good example of application on the condition of a discrete random variable. Okay, so hopefully it will covers all the revision for discrete random variable. Now we look at continuous random variable. See how the PDF, I always say PDF to my student. Probability density function is easy to say PDF. See how it is displayed. The PDF is f of x. The first value is k for all x from 0 to 1. The interval is very important, okay? You have to look at the interval. X is included. Sorry, 0 is included. Then we have k over x squared. X is from 1 to 4. 1 is included. Okay, and 0 otherwise, meaning that outside this interval, the function is not defined. So show that k is 4 over 7. And calculate the mean and variance. Okay, this is just a revision. So to show that k is 4 over 7, Okay, this is the function on top. So what must you do? For discrete, we show that the sum of the probabilities is 1. So for continuous, we show that the area under the graph is 1. Okay, so look at the interval. From 0 to 1, the function is k, plus the interval 1 to 4, the function is k over x squared equal 1. So this is what I meant. Make sure you still remember how to integrate. Okay, it's in term 2, right? Semester 2. So this is kx from x0 to 1. This is minus k over x from x1 to 4. Okay, the rest is just substitute the upper limits and the lower limits. This is k, negative k over 4 plus k. Okay, the rest is just calculation. Therefore, your k is 4 over 7. Okay, can you see the difference between discrete and continuous? So to find the mean, okay, we use this formula. Can some of you calculate? Anyone of you has managed to calculate?
Students, please try.
To see the difference between the expected value of discrete and continuous. So for continuous, we have to use the integration of the product of x with its function. So look at the interval again. It's exactly the same as mean, just that now you need to multiply by x. So straight away you can integrate. Okay, this is k. Okay, what is the mistake here? Can anybody detect the mistake? I can see the mistake already. Can anybody detect the mistake here? Okay, spot the difference, spot the mistake. Can anybody spot the mistake in the integration? Anybody?
Yes, class, can you see the mistake there?
Supposed to be kx squared over 2. Okay, it is a typo error here. Everybody is quiet. Okay. Okay, k over x is k ln x. So substitute. Okay, substitution is correct because x squared. We are lucky because x is 1. So 1 squared. Okay, x squared. Thank you, Guy. Thank you, Guy. You noticed the mistake. So you are alert. Okay, you are still alert. Thank you, thank you. X got no power. Okay, good. For the equation. Thank you, Leong. All right. So since we are safe because x is 1. So kx squared, k1 squared is still 1. So we are safe. So some teachers said it's being recovered. Okay, k over 2 plus k ln 4 minus k ln 1. Okay. So lastly, I substitute the value of k, 2 over 7 plus 4 over 7 ln 4 because ln 1 is 0. Then you can leave your answer in ln. Okay, here I have simplified in factor form. Okay, you can leave as 2 over 7 plus 4 over 7 ln 4, or in factor form 2 over 7 times 1 plus 2 ln 4. Okay, you can leave your answer in terms of ln. Okay, next. Okay, to find the variance, you have to find ex squared first. So this is the formula. Okay, this time I have typed it correctly, kx squared. Okay, simplifying, kx squared times x squared is k. So integrating, okay, this is typed correctly, kx cubed over 3, kx, substitute the upper and lower limits. So you have 10k over 3, substitute your k just now, we have 40 over 21. Hence, the variance of x, we use the formula. Okay, one thing about probability distribution is very dry, it's just knowing how to use the formula, okay? So ex squared is 40 over 21 minus the mean squared. Okay, here you have to press the calculator. Okay, guys, is it wrong if I didn't leave the answer? No, it's not wrong. You can leave in decimal form. Okay, you can leave in decimal form. But make sure it's at least 4 decimal places. But yeah, But in Maths M, we accept 3 significant figures. I don't know about Maths D, okay? But to be safe, at least 4 significant figure, okay? It's not wrong to live in decimal form. Just that when you live in long form, you are safe. I mean, you save time. You don't have to evaluate. You save time evaluating. That's all. Okay, next. Okay, now the first part I think you can do, show that K is half using the concept just now that the area under the graph is 1. Okay, now finding the cumulative distribution function is tedious. It's tedious, it's not difficult, it's just tedious. And then sketch the graph of the cumulative distribution function. Okay, we have several functions here. Okay, and then find the probability of x between 3/2 and 5/2. Okay. Can you take down the question? Find k equal half. Show that k is half. Okay, this is very simple. Find the cumulative distribution function. Sketch the graph of the cumulative distribution function. So please take note, read the question carefully. It's cumulative, not probability density function, okay? And find the probability of x between 3/2 and 5/2 inclusive. Okay, let's look at the answer. Okay, for A, I'm going very fast. We use the area under the graph is 1. Okay, look at the interval. The interval represents the limits and the function used. Okay, integrate, substitute the limits, okay, and show that k is half, okay. Right, now, the next part, to show that, to find the cumulative distribution function of a continuous random variable. Okay, this is the PDF. I already substituted k as half. Okay, I always tell my students, you look at the interval. The interval is very important because when you define the cumulative distribution function, you have to write down the interval. So we have x here, which is greater than 1. Okay, so we do the opposite. For all x less than equal 1, which is not in the interval. So f of 0 is 0. In other words, f of x is 0 for all x less than equal 1. Okay, we start off with f of x is 0. And then I look at the last interval. Here we have x less than equal 3. So the opposite is x greater than 3. So we know that when you add up the probability, it must be 1. The area is 1. So I always tell my students, start off with f of x 0 and end first with f of x equal 1. Then we do the middle cumulative distribution function. So now, so we have x less than equal 1, so f of x is 0. So next we look at this. 1, okay, less than x less than equal 2. So you have to integrate from negative infinity to 1. Okay, some book they just ignore this, okay? But for me, I just want to explain. Outside the interval, the function is 0. So anything integrate 0 is 0. And I'm using the function t because it's easy for us to substitute the limits in terms of x. I do not want to get confused. X and you substitute with x, okay? So most students will get confused. They think that they have substitute, but then they have not substitute. Okay, now. So the integral of t minus 1 is t squared over 2 minus 2. Okay, substitute. So the cumulative function in the interval of for x in the interval of 1 and 2 inclusive is this. Okay, half x squared minus x plus half. Okay, the next interval, x greater than 2 and less than equal 3. So the function, we start from 0 because from negative infinity to 1, the function is 0. But from 1 to 2, the function is t minus 1. From 2 to x, the function is half. Okay, integrate this with limits 1 and 2. Integrate this with limits 2 to x. Substituting the lower and upper limits, we have this. Okay, right. Is this answer complete? Is it complete? What must you do the next step? The question states, find the cumulative distribution function. So you must leave your answer in terms of function form. Therefore, the cumulative distribution function, big F of x. Okay. So we have this as the answer. Next, we need to sketch. Okay, sketch the graph of the cumulative distribution function. So to sketch the graph, we look at the interval again. Okay, we have x less than equal 1. Okay, the function is 0. Then we have x between 1 and 2 is a quadratic curve. But normally what I do is I just substitute 1. Okay, good guy, put to distribution form. Okay, right. Then substitute 1. Okay, we have 0. Substitute 2, you have half. Okay, this is continuous. Probably when I'm doing this one, it should be joined, yeah? So many, all these are joined. And then when x is 2, I substitute, still got half. And when x is 3, in the third function, you have 1 onwards. For all x greater than 3 is 1. So that's how I sketch the graph. So it's very important that you label the axis correctly. Without the axis being labeled, you lose 1 mark. But with the axis label, you will obtain the full mark. Because the last mark is everything must be correct. So read again, for all x less than equal 1, f of the value of, for all x less than equal 1, we have 0. Between 1 and 2, we have the quadratic half x squared minus x plus half. And then between 2 and 3, we have the straight line, the linear line, half x minus 1. And for all x greater than 3, we have f of x equal 1. Okay, so that's how we do the graph sketching. Okay, now to find the probability, we can use two methods. The first method is using the cumulative distribution function. So why did I say we can use two methods? Because in the question, there's no task word hence. So when there's no hence, you can use another method. But if there's a task word saying hence, so you have to use the cumulative distribution function. So just now already given you the formula, it's just f5/2 minus f3/2. So to find which function, we look at the interval again. 5/2 is 2.5. So this is the function. So substitute 5/2 into the function. Okay, 3/2 is in this interval. So the function is half x squared minus x plus half. So substitute x as 3/2. Okay. Then the rest is solving, you get 5/8. Okay, the other method is using the PDF. Okay. What does this mean? Okay. The integral of the first function x minus 1 from 3/2 to 2 plus the integral of the second function half from 2 to 5/2. Okay, we look at the interval, see which function. And then we integrate. We substitute the lower and upper limits. We still have 5/8. So look at the question. If there's no hence, you can use the PDF. But if the question say hence, then you have to use the cumulative distribution function. Okay. Even though if we get correct 5/8, but since the word hence is there, if we were to use the PDF, straight away 0 mark. Okay. So please in the exam, take note of the word hence. Okay, the last question.
Cikgu Zana.
Hmm?
There was a question just now about the sketching the graph. X guy, he asked the include and does not include marking is not necessary.
Again, what does it mean?
Means when we sketch the graph, the boundary there, we need to mark the include.
Or the dot you mean?
Yeah, correct.
This is continuous. I think everything is included. So it's continuous, so we don't have to put the dot. Am I right? Max M, we all tak include. Unless it's just one function, for example, half. It's not continuous. So we have to put a dot half. Okay?
Yeah, since it is continuous, then no need.
No need. No need the dot. Unless it's not continuous, then you have to have the dot. Okay? Okay. Is that answering that? Have that answer you guys? Hope guy understood my explanation. Okay. Okay, we move on to the next. Okay, yeah. I can't remember. Go to slide.
It's already 6 o'clock.
Okay. I think they can do the last question on their own. Let me show the question. Can I just show them the definition, the concept of mean, median, so the quartiles of the continuous random variable? Just the concept. Okay.
Yeah.
So these are the quartiles, how to find the first quartile for a continuous random variable. Okay, we use FQ1 is 1/4, or you can use the PDF. If this is 0, from 0 to Q1 equal 1/4, first quartile. This is how we get the first quartile of a continuous random variable. For the median, 50%, we can divide the graph into 2. So the integral using PDF from A to M is half, or from M to B is half. We can integrate either one. Or you can use the cumulative distribution function, F of M is half. And the third quartile, okay, we use the cumulative distribution function, FQ3 is 3/4. Okay, so these are the concepts that students must know. The quartiles of a continuous random variable. You equate with first quartile, 1/4, 25%. Median, 50%, 1/2. Third quartile is 3/4. So you can have a look. This is what I meant. Okay, now how to know which interval function to be used? So just substitute first F1. F1 is 1/3, is still less than half. So the median must lie in this interval. Okay, that's a technique. Okay, right. Okay, the rest you can check in your past year. Okay, getting the PDF, you differentiate. And don't forget to give your answer in the function form. Okay, that's all. Thank you for watching. Don't remember to subscribe my channel. Okay, Teacher Eileen.
Yeah. So we have reached the end of today's session. So congrats to those who are able to follow our session from the beginning till the end. So before we end our session for today, can all of you please stop posting your comments for a minute and click the subscribe button and activate the bell icon so that you will not miss the next class session. So then if you find that this lesson was beneficial, click like and share to your friends on your social media. So spread and share the goodness. And please take note, the link will, now the link for the certificate is in the chat box. It is given token. It is given as a token of thank you for your dedication in joining the free online class today. So please take note, the link will end in 30 minutes after this live. So make sure to use the EDD email only to log in. So incorrect email used will not be entertained. So if you haven't got one, please apply. And if you wish to get more information on the online classes, go to www.academyyoutuber.com. And to those who haven't joined EDD Junior Telegram, please do so. Then before we end, let's hear a few words from our teacher. Teacher Im?
Teacher Im is like trying to advise students to continue studying in the chat box, because I do feel that God is giving you a chance, okay? Because your exam time have been dragged, you have like the holiday after the other SEM 2 exam, you have like 2 weeks before your SEM 3 exam. It's actually a God-given gift. If you see last time your senior, they don't have this kind of privilege.
Yes.
They finish one exam, they continue second exam, they finish another one, they have to continue. So make good use to it. Make sure you continue studying. Make sure you do more questions, see more questions, but don't read the questions. Okay? Look at our videos, but don't just watch the video. Pause the video, do the question, then only continue. That's why we are here. Okay, we want to give you a chance to continue studying. Okay, that's all. Grumbling like a normal teacher. Bye.
Okay.
Bye.
Yes, yeah. So I also agree. So the way you watch our videos, suppose it is not watching, finish, then turn off. Then I think you cannot learn anything. So suppose when you watch, the time you watch, you pause. When you come to a question, you pause and try the question. Then after that, get the answer from the video. Like that. Then after that, after the video, you got to do your own exercise. It is not when you watch the video, you understand, or you will be happy. No, video is just a guide. Okay, if you want to master certain topic, you still need to do exercises.
Yes.
Yeah.
True.
Okay, so once again, I would like to thank all the students for joining today. So please share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all the teachers throughout Malaysia for all the students throughout the country. So thank you, Chu, for being a YouTuber Academy supporter too. So I think that's all for now. So see you another session. Remember the hashtag bermula percuma, selamanya percuma. So stay safe until we meet again next week, same day and same time. So bye-bye.
Bye-bye.
Good luck and bye.
Yes. Yeah, good luck and bye.
Keep on studying. Okay?
Yes.
Tuition online percuma. Tuition online percuma. Layari www.academyyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuition online percuma, mestilah Akademi YouTuber.
Dibawakan kepada anda oleh Akademi YouTuber.
Okay.